Yo, 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 this is Coach Ray back on the mic, talking about a radical review. All right, I'm going to start by recapping what we did in the first set of notes, because this notes took a couple days, and we're going to see if we can get all the way through the rest of it. All right, starting with example 1. Let me make this big. Starting with example 1, we were simplifying a square root. We talked about if you're simplifying square root of 25, it'd be super simple. You just switch it to a 5 because it's a perfect square. If it's not a perfect square, like 32, you break it up. All right, and how you're trying to break it up is you want one of them, this one right here, to be the biggest perfect square possible. 16 is a perfect square. And you want this to not be a perfect square, or it won't be anyway. Okay, so that way your perfect square turns into a whole number. In this case, it turned into a 4. When we did this problem, we talked about you could break it up into 4 and 8, because 4 is a perfect square, but then your 8 would be able to simplify further. So we want the biggest perfect square. All right, example 2. All we added was a variable in there, x squared. X squared was a perfect square, though, because x times itself equals x squared. So this perfect square of x squared just turned into a x with no house. All right, over here with my 48, I did the same thing as example 1. I broke it up into 16 and 3. So my 16 turned into a whole number 4. And the other thing we talked about is houses move to the back, non-houses move to the front. Okay, so there was our example 2. All right, example 3. Same thing. I got my square root of 50. I got my square root of x to the 9th. I got my square root of y to the 6th. Y to the 6th is a perfect square because y cubed times itself equals y to the 6th. In fact, we talked about how every even power, every even exponent would be a perfect square because you could just cut it in half. All right, x to the 9th, not an even exponent though, obviously the 9. So we had to break that one up. When we broke it up, we got our biggest perfect square was the biggest even number, that was x to the 8th. The other one was just x to the 1st. So this x to the 8th turned into x to the 4th, and this guy had to just stay the same. All right, so then we just rearranged. We moved our houses to the back, non-houses to the front, and then we combined back our square root of 2 times square root of x. You can put them back together, and you just get square root of 2x. Okay, there's our recap of our first 3 examples. I'm going to keep moving unless there are any questions. Yeah.
Can I go to Mr. Brown College and get my phone?
Yep, you're just going to miss stuff. All right, example 4. Example 4 you may have never done before, okay? So pay close attention here. The first thing you need to know about example 4 is this. Radicals are like variables. So 3 times the square root of 20 is kind of like 3x. So you can't do it. You can't put those together. 3 times x is not something. You just write them next to each other as 3x. Okay. So then if you got square root of 45 over here, that's just a different radical than the square root of 20. So it would be like a different variable. So this would almost be like 3x plus y. We cannot combine 3x and y because they're not like terms. So if I was asking you to simplify this, you would technically be done because there's nothing you can do to combine or anything like that. Okay. Except when it comes to radicals. So I'm going to get rid of this. When it comes to radicals, we can simplify both radicals and maybe they turn into like terms. Okay, so square root of 20. I'm going to break up. My biggest perfect square is 4, and then it's also times 5. And I got to keep my 3 out here. Keep my plus in there. When I break up my square root of 45, biggest perfect square is 9. Okay, and then it's going to be times 5. All right, next line. Clean things up. Watch carefully so you don't miss this. I'm going to do 3 times 2 to get 6. Everybody see that? I said it weird, but 3 times 2, because the square root of 4 is going to turn into whole number 2, and that's going to give me 6 square root of 5. Okay, back here, square root of 9 is going to turn into the whole number 3, and I got my square root of 5. Okay, I've got like terms. My square root of 5 and my square root of 5 are the same. So it's like a variable. You treat radicals like variables, so it's kind of like I have 6x plus 3x. And I like saying it like that for a reason. 6x plus 3x is 9x. And clearly I didn't write an x. But notice that I did not change that to square root of 10. Okay, it just stays square root of 5 because it's treated like a variable. 6x plus 3x would be 9x. Yeah?
Did you get the 6 from?
I got 6 from doing, the question was where did I get the 6? From doing the underline 3 times the underline 2. The underline 2 just looks funny. Okay?
So for these problems, will the square root for always be the same?
The question was, for these problems, will the square root always be the same? And the answer is no. One of the examples we'll get to today, it's not. Great question, though. Okay. I don't want to answer what we do because I'll get to that in the example. But if they're the same, combine them. If they're not, I'll show you an example later. All right, great questions. Example 5. Same thing, only now I got minus. They're not like terms right now because I got two different square roots, but I'm going to simplify them both. 12 is probably going to be square root of 4 times square root of 3. 27 is going to be square root of 9 times square root of 3. Okay, in my next step, clean this up. Negative 3 times 2 gives me negative 6. Again, this is going to turn into a 3. Okay, and again, in this case, I did have like terms, so I'm happy about that. So now I can combine these. Okay, negative 6x minus 3x is negative 9x. One second. All right, Coach Ray back here. Sorry for that awkward silence. We are on example 6 in radical review. Example 6 is multiply. Okay, and don't forget, multiply is simple. We're allowed to take a radical and break it apart into two things that multiply, so the opposite's true. We can take two radicals and multiply them back together, and I think that'll help to start. So I'm going to do that. So I'm going to put these back together. 2 times 18 is 36. X to the 7th times x squared, I'm afraid for you guys. I visualize 7 x's all multiplying each other times 2 x's multiplying, so that's a total of 9 x's. So I now have x to the 9th power, and this is all being square rooted. Okay, you guys are struggling, and that kid should go somewhere. All right, so let's go. I could break it up. I don't know if I need to, but I'll do it anyway for the notes. Square root of 36 times square root of x to the 9th. Okay, so square root of 36 obviously going to be the whole number 6. X to the 9th is not a perfect square because it does not have an even power. So I've got to break this up to x to the 8th is the biggest perfect square, or the biggest even number. Okay, and then my answer is just going to be 6. That's going to end up being x to the 4th, because x to the 4th times itself is x to the 8th, and this stays the same. That's it. Questions, or am I moving on? Alright.
So you could do that whenever you want, basically?
Do what whenever I want?
Like, if it's not thing, you go x8 and then another one? You could do that?
Yeah.
Whenever
If
you
it's
want?
not, yeah, if it's an odd number, just take the biggest even number, and then the other one will just be 1. All right, example 7. We are looking at distributive property. Okay, so distributive property looks like this, and it's multiplied. Okay, so I'm going to do 9 square root of 5 times square root of 7. And remember, outside the house and inside the house can't mess with each other. Okay, if you're inside the house and inside the house, you multiply by each other, and they can go back together to be one house. Okay, square root of 5 times square root of 7 is square root of 35. Okay, hold. Coach Ray back. This is the worst video ever. I've paused it twice. There's probably some awkward silences in there. But someone from second period came to visit third period, and you know what I say about second period. So, anyway, second multiplication. Second multiplication is 9 square root of 5 times square root of 10, so the same thing's true. My 9 stays out front, but I can combine my square roots. Okay, and again, they're not like terms currently, so I probably want to try to simplify both radicals, and then see if I get like terms that combine them. Square root of 35, let's start with that. I think the only two numbers other than 1 and 35 that multiply to give me 35 are 5 and 7. Neither of which is a perfect square, so neither of them would turn into a whole number. So 9 square root of 35 is simplified. So I might be done, or at least close to done, because I can't simplify that further. But I look over here at this 50. Can the 50 be simplified? Yes, so I have to. If it can be simplified, you must. Okay, so square root of 25 times square root of 2. Bring this other stuff down. Okay, so I got 9 square root of 35 plus 9 times 5. You okay with that? Okay, 9 times 5 is 45. Square root of 2. Alright, not like terms. Square root of 35, square root of 2, not like terms. I cannot combine them, meaning this is as simple as I can make it. The directions say to simplify, this is as simple as I can make it. Questions, or am I moving on? Okay, next one. Square root of 2/7 is the same thing as square root of 2 over square root of 7. Square root of 2/7 is the same thing as square root of 2 over the square root of 7. And there's like laws of simplifying, like what is simple, what's not. And mathematicians, when it comes to simplification, hate stuff in the denominator. We really don't care about the numerator much. We just want the denominator as clean as possible. It'll pop up throughout the entire year. So one rule of simplification is you cannot have square roots in the denominator. Okay? And listen very carefully to this question because I want you to think about this. I only care about square root of 7 being a square root. I really don't care about square root of 2. So I'm just going to mess with this bottom square root of 7. I can multiply square root of 7 by something and it'll turn it into a whole number. I can multiply the square root of 7 by something and it'll turn it into a whole number. Anybody know? You know. Answer.
What? Oh, 7.
Square root of 7. Check it out. If I do square root of 7 times square root of 7, put them back together, you get square root of 49. Square root of 49 is obviously going to turn back into a 7. So if you take any square root, multiply it by itself, it's going to turn into a perfect square, obviously, and then turn back into that number. All right, beautiful. But here's the thing. You can't just change this problem because you don't like it. Right? So I can't be like, oh, I don't like square root of 7 in the denominator. I'm just going to multiply it by something and turn it into a 7. I can do whatever I want as long as I don't break the law. And I have broken the law at this point. Okay? To stay legal, I have to do this. If I multiply by square root of 7 over square root of 7, that's the same thing as 1. I multiply 1 by anything, I didn't change it, so I didn't break the law. It'll look different, but I didn't change it. Okay, so here's what I get. I get on top, you can put those back together, I get square root of 14. On the bottom, square root of 7 times square root of 7 is square root of 49. Square root of 49 turns back into a 7. Look at the square root of 14 real quick. Can that simplify? 2 and 7, right? But can either of those a perfect square that would turn into a whole number? Nope. So that can't simplify. All right, can I reduce? I got a 14 on top, 7 on the bottom. Can I reduce?
Yeah.
No. Okay, it's kind of like this. Over here, when you had 9 times square root of 35, those can't mess with each other. You can't do 9 times square root of, or times the 35. What's in the house and what's out of the house can't mess with each other. So the 14's in the house, 7 is out of the house. They can't mess with each other. We're done. Okay? Alright, example 9 is going to take extra time to explain. So I'm going to stop there at example 8 and then I'll just do one more video for example 9.